Hello everyone, and today is the first video that I'm gonna upload for IOQM 2026, and here is the first question. This is a non-PYQ of IOQM, and hopefully this will not coincide with other resource. So here's the first question, but before I read and explain this question, make sure you pause this video and try it out by yourself. So I hope you must have tried it out. So let us read the question. Let xyz be the side lengths of a non-degenerate triangle such that x, y, z are integers satisfying this condition. Find the number of such triplets xyz that satisfy the following equation. So here is the given equation, and we have to see the number of triplets. So clearly this is a case for count. This is clearly a counting case where we have to classify into cases and start counting. Now, if you look at this messy but similar looking equation, you see that there are three forms of terms, like you have x cube term, then you have xyz, and you have x plus y plus z. So our goal is to make sure that this equation is converted into singular form, like x cube term, x cube form, or xy plus yz plus zx form, or whatever it may be. Whatever comes we will see here. So first goal is to convert into single form. Now how do we do it? Very simple, we have to use algebraic identities over here. So let us see how we can use it. So one thing you can observe is if you place these three xyz into LHS, you will come to know that it is going to be something like this: x cube plus y cube plus z cube minus 3x y z equal to 133 times x plus y plus z. Now if you look at this expression, it is very clear that we can convert this in form of x plus y plus z, so that we can reduce the form from three forms to two forms, right? Because we have three forms. One is x cube form, other one is xyz, another one is x plus y plus z. So if I write this algebraic identity over here, hopefully this will be a familiar one for you. So it is going to be like x plus y plus z times x square plus y square plus z square minus xy minus yz minus zx. Now this should be equal to 133 times x plus y plus z. So if I copy this, so here's the expression. So let us bring this x plus y plus z in one side. So we will get something like this: x plus y plus z times x square plus y square plus z square minus xy minus yz minus zx. So let me copy paste it here. Okay, and here also put minus 133 because we are taking a common, right? So we will have minus 133 as well, minus 133, and this should be equal to 0, right? Now clearly product of two terms is becoming 0, so this means that either this term has to be 0, so either this term has to be 0 or this term has to be 0, or both can be 0. Now let us see if first term is 0 possible or not. So if you see, x plus y plus z cannot be 0 because x and y and z, they indicate the sides of a triangle which cannot be negative. These terms cannot be negative, and Sum of positive numbers cannot give you 0 anyway. Sum of positive numbers cannot give you 0, and since this is a non-degenerate triangle, we have to only accept real values. They cannot be complex numbers, so clearly 0 is not possible. So that's why this is an invalid case. So the only case is that this second term should be equal to 0. So if I copy paste this second term over next page, here you will get the second term equal to 0, which indicates that this expression should be equal to 133, something like this. Okay, now if you look at this equation, still you have two forms. One is x square form, other one is xy form. We have to bring this also into one form so that we can deal with counting easier. Okay, so how do we bring this into one form? So here is one more familiar identity, that this expression in the left hand side can be also written as half times x minus y whole square plus y minus z whole square plus z minus x whole square, and this should be equal to 133. Okay, now if I bring this half to the right hand side, it should be 266. So sum of these terms should be equal to 266. So clearly whatever was our goal, we have fulfilled it, that is to bring these terms into one form. So now they are in one form. Now let us deal with the counting. Now here there are two such observations we have to notice. First observation is that, we clear this around. So first observation that you have to notice is that if this is A, let me use other color. If this is A, this is B, and clearly this has to be A plus B, right? I hope you can see this. Okay, and this is the first condition, and second condition is that sum of squares should give you 266. This is second condition, and third condition is that x plus y should be greater than z. Why? Because this is triangle inequality. So we have to satisfy these three conditions. Now if you look at the second condition that I said, which is this equation condition, it is visible that sum of squares should give you 266. The ending digit is 6. Now if you see, the sum is giving you 266. Now if you look at the first condition given in the question, 1 less than equal to x less than y less than z less than equal to 40, it is clearly visible that maximum difference can be 39 when you take z as 40 and x as 1. Maybe you can take y as something like 37. Here you will get maximum difference is 39, and if you see minimum difference, it can be 1, and it should be, because beyond less than this it is not possible. When you take y as 5 and x as 4, this is just an example. Okay, so one thing is clear, that maximum difference can be 39 and minimum difference can be 1. So let us go through it. Now if you see, sum of squares is giving you 266, right? Now if you look at all squares from 1 square up to 39 square, definitely this is not possible, because this is greater than 1500 but less than 1600. So that's why we are not going to take all difference from 1 square to z square. Then tell how much we can take. Very simple, because if you see the sum is giving 266, so the maximum square can be from 1 square to 16 square. Why? Because this is giving you 256. Now if you take 17 square, this is going to give 289, which is not possible for this case, for that equation. So that's why the difference that we are going to take is from 1 to 16 square, 1 square to 16 square. Okay, so I hope you have got this observation. Very simple observation, no big deal. Okay, now one more thing we have to see. Then the last digit is giving you 6. So if you see the squares last digit, you will come to know that it can be either 1 or 4 or 5 or 6 and finally 9. This will come from 1 square, 9 square, etc. This will come from 2 square, then from 8 square also you will get, and this will come from all 5 squares. This will come from 6 square, and this will come from 3 square, and it will come from 7 square as well. So 1, 2, 3, and here also you will get 4 square, 5, 6, 7, 8, 9. So, and even 0 is also possible. 0 is also possible, but it should be even number of zeros. Even number of zeros. This will come from 10 square. Okay, so this is one more observation that we have to see, and we want the ending digit to be 6. So let us see which cases are possible. Now this is can be achieved only by brute force. There is no special trick that you can use it to derive the cases. So first case is when you take first term, let's say a as 1, case 1, a as 1, b as 11, and a plus b as 12. Now how am I saying this? Because if you square these and sum up together, you will come to find that it is going to be 266. So if you see a square is 1, b square is 121, and if I call this c, then c square should give you 144, and if I sum this up, this should give you 266. Okay, so clearly this is one possible case. So now if we start counting the triplets, a square plus b square, let me copy that expression. Okay, now if we have this expression over here, then we will come to know that a plus b. Okay, yeah, so now if you see the first question, the first condition given, it is stated that x less than y less than z. That means we cannot have dual cases over here, like x minus y and y minus x. This is not possible. Only this is possible, this is not possible. Okay, so that's why instead of writing as x minus y inside this whole square term, we will write simply y minus x. Even though x minus 5 whole square and y minus x whole square doesn't make any difference, but still we will write y minus x whole square. So y minus x whole square Then similarly if you sum, you will get z minus y whole square, and finally you will get z minus x whole square, and this should be 266. Okay, so let me remove the equation above. Okay, so we have removed it. So now one possible case is that now if we place this as 1, this as 11, and this as 12, then what triplets are possible? Now if we start from the minimum case where x is 1, then y should be 2, then y here 2 is possible, and 1 will come. And if you see z should be 13, right, because 13 minus 2 is 11, and here also 13. So clearly 2 minus 1, 13 minus 2, and 13 minus 1 is giving you respectively 1, 11 and 12. But there is a problem. The problem is that this is not satisfying the triangle inequality, because if you see y plus x, this is less than z, which is not possible. So this triplet is clearly not possible. So from which triplet is it possible? If you look at it very carefully, this is going to give you 3, next will give you 4 with the 14, then 5 with 15, big sum, okay, 2 plus 1, 3, then 4, 5, 6 with 16, oh sorry, not 3, 4, 5, sorry. Now if you look at next triplet, like if you take 3, 2 and 14, 3, 14, 2, this is going to give you 5, this is also less than 14. If you take 4, 3, this is going to give you 7, this will give you 15, right, z should be 15. Then if you take 5, 6, this will give 11, this will give you, this is the sum, okay, 3 plus 2, 4 plus 3, 2 plus 1, 3, then this will give 16, still less than. If you take 6, 5, then oh wait, sorry. If you take 5, 4, this is going to give 9. Here 6 plus 5, here 5 plus 4, 9. Then for 11 you will get 18, 17. Then for 7, 6, here you will get 13, and here you will get 18. Then for 8 and 7 you will get 15, here you will get 19. Then for, if you keep going, you will get 17, then you will get 20, 18. This is the sum here, okay, like 9, 8, 10, 9, oh sorry, this is 19, this is going to be 21, then 11, 10, this is going to be 21, this will be 22, and finally when you hit 12 and 11, this is going to be 23. Till here you cannot take these as triplets because it is not satisfying the triangle inequality. After this only you can take this, like when you pick, if I copy this and clear up all these things, wait, clearing up, okay, fine. Now if you take y as 13 and x as 12, y as 13, x as 12, y as 13, x as 12, then here you are going to get 24, same 24 will happen. From this triplet answers you can consider it, because 13 plus 12 is 25, which is greater than 24. So clearly this is a possible triplet. From here all the way, now if you see among y, x and z, z is the larger one, so clearly z can go till 40. If z goes till 40, now why I am saying z can go till 40, because if you make x or y 40, then z has to be beyond 40, because of this first condition, x less than y less than z. Now if you keep y as 40, this cannot be 40, but this y less the condition, so that's why the maximum boundary is that keeping z as 40. Now if you keep z as 40, here you should be getting as something like 29, so that it will give 11, then y should be 29, then x should be 28, here it is 40, and finally 28. So if you see number of cases over here, you will get to know that it is actually 28 minus 12 plus 1, which is 17. Okay, so here there are 17 cases for first one, where first term is 1, second term is 11, and third term is 12. Now is there any other possible case within this triplet, which is this combination? Yes, definitely. You can keep y minus x as 11, z minus y as 1, but z minus x should be only 12. It cannot be 11 or 1, because if you see third term, if you keep this as c, if you keep it a, b and c, very clear, it is very clear that c should be a plus b, a plus b, so that's why c cannot be either 11 or 1, c has to be 12, but a can be 1 or 11, b also can be 1 or 11, 11 or 1. If this is 1, this is 11, this is 11, this is 1. Now let us take the second case over here. The second case is where you take a as 11, where you take a as 11 and b as 1. Okay, now here you will get more cases compared to the first one. Let us see how. So let me erase off all these things. Okay, yeah, erased. Now if you look at the second case, y minus x should be 11 and z minus y should be 1, but z minus x should be the same 12. Now if I start x with 1, this will be 12, this will be 12, this will be 13. Now if you see, this triplet is not possible because y plus x is equal to z, and that will not form a triangle at all. So first case is not possible. So if we start from the second case where x is 2, then this will be 13, and this will be 13, this will be 14. This is possible because x plus y or y plus x is greater than z. This is a possible case. So here z will be 14 and x will be 2, and if you see clearly, z is again maximum, so you can take this z till 40, then you will get a 39, and here also it's be 39, and here it is going to be 38, sorry, not 38, here it is going to be 28, right? 28, this will be 28, and here it will be 40, this will give you 12, this will give you 11, this will give you 1. So if you see number of cases, it is 27. Why? Because we are eliminating the first one, which is 12, 1, 13, here you will get 12, this case we are eliminating, right? So if you see from here to here it is 28, from here to here it is 27. So in second case, 27 triplets are possible. Okay, in first case 17 triplets are possible. So overall how much you are getting? 34, 44. 44 triplets are possible till now for first two cases. Okay, now let us go to the third case as well. Now what could be another combination of sum of squares? Now that you have to see, that requires a lot of observation. Now how do we get that observation? Very simple, by the method of last digit. Whenever it comes to squares, this last digit is very famous. Now if you clearly see, for the first two cases we have taken 1, 11, 12. That means 1 comes 2 times and 4 comes 1 times, right? 1, 120 and 144. Now if you sum of 1 plus 1 plus 4, 1 plus 1 plus 4, this will give you 6 ending digit. Now if you take the second case, if you think a little bit, you will come to know that 169 is also possible. 1 plus 6 plus 9, this will also give an ending digit of 6. Okay, yes, ending digit 6. So that's why this is also a possible case, but simply taking the ending digit is also not enough, because we have to satisfy this condition as well. So if you see, for 169 as the ending digit, one more possible case can be, wait a second, let me clear it up. Okay, so I cleared the previous one. Now let me read the third case. Now for 1, 6, 9, the possibility is that you can take 9 square plus 7 square equal 9 square plus 7 square plus 16 square, 9 square plus 9 square plus 4 square plus 13 square, right? This will also give you 266. Check it if you wish. 9 square is 81, 4 square is 16, and the 13 square is 169. If you sum it up, you will get 266. Okay, I've done this before, so that's why I'm doing a bit fast. Okay, so if I keep here, let me copy the fourth case also. Okay, yeah. If I keep this as 4, this as 9, this as 13, difference. Okay, y minus x 4, z minus y 9, z minus x 13. So if I keep x as 1, this has to be 5, this will be 5, this will be 1, and your z is going to be 14, here also 14. Clearly this is also not possible because 5 plus 1 is 6 and 6 is less than 14, which is not possible. So if I start saying again, like 6, 7, here you will get 15, 8, 16, 9, oh sorry, here you will not get like this. Now if I keep it as 6 and 2, you will get 8. So this is going to be, this will jump by 2, whereas this will jump by 1, right? So here 8, here 15, for 9, 16, oh sorry, 10, 16, and for 12 you will get 17, for 14 you will get 18, for some was 14, for some 16 you will get 19, then for 18 you will get 20, then for 20 you will get 21, and for 22 you will get 22. Okay, and from here you can start taking the cases 24, 23, right? When you will get 24, if you see here you will get 3, 4, 5, 6, 7, 8, 9, 10. So this should be 10, and this should be 30. Oh sorry, this should be 14, right? 14 plus 10 is 24, and difference is 4. So from this triple you can start taking into account because it satisfies the triangle inequality as well. So if you remove the previous invalid cases, okay, you will get this as 14, this is 10, this is 14, this is 10, then this has to be 23, and here also 23. Okay, so from here you can start taking cases. Again z is maximum, so you should take till 40. If you take this as 40, this is 31, this will be 31, then this will be how much? This will be like 35, right? This will be 35. Oh sorry, this will be 40. Hey wait, is there something wrong? Oh sorry, y is 31, right? I'm sorry. This will be 31, this will be 31, this will be 27, this will be 40, this will be 27. Now if you see number of triplets over here, you will come to know that this is difference of 17, then plus 1 18. So here there are 18 triplets possible, here you have 27. Okay, and the first case is 17, right? And the first case is 17. So now we have 18. Now what can be the fourth case? Very simple. If you keep 9 here in y minus x or a, if you keep 4 in b and c is same 13, then that can be the fourth possible case as well. Now if I keep this as fourth case, this can be 9, this can be 4, this is still 13. Now x, if you start with 1, this will be 10, this will be 10, this will be 14, Clearly this is not possible because 10 plus 1 is less than 14, does not satisfy the triangle inequality. Here you will get 11, here you will get 13 for 15 as z, then for 15 you will get z as 16, then for 17 you will get 17. This is also not possible. And when it comes to 19, that means when you take z as 2, 3, 4, 5 and 14, and here it will be 18, 14, and this is possible because 19 is greater than 18. So if I eliminate the above cases, okay, and if I count this one, okay, so this is 14, y, x is 5 and z is 18. Now clearly z is second maximum, so I can take z till 40. If you take z as 40, your y will be 36 and this is 36 and this will be 27 and this will be 40, this will be 27, it gives you 13. Now we see number of cases over here. Here you are going to get 23, right? 27 minus 5 plus 1, right? I hope you understand why I am taking a plus 1, because I am counting all triplets from first till the last, so that's why plus 1 is required. So we have classified our case into 4, and finally we came to know that first case is giving you 17, second case is giving you 27, third case is giving you 18, and fourth case is giving you 23, right? First case, second case, third case and fourth case. Now if we sum these 4 numbers, we will finally come to know that this is going to be 85. So the final answer for this question should be 85. Okay, and I hope you must have understood the solution. If you did not understand, then please make sure you comment it in the comment section so that I can respond it as soon as possible. So that's all the solution for this video, and thank you so much. Bye.